Hello, how are you doing? Hopefully well. Hopefully you're enjoying your little break here. So this is the video I wanted you to watch in lieu of a midterm. And I'm sorry it's taken so long to get out to you. I've had quite a week. I'll tell you all about it when I see you again on Thursday. I'm going to show you how to find a solution to a definite integral. We talked about that a little bit before break. An integral is the next phase of calculus we're studying. We find them by taking antiderivatives, exactly the opposite process of what we've been doing. I'm going to show you that connection later on. But today I want to explain very briefly what this means geometrically and how do we actually solve it by hand. So what you're looking at here is read this way: the integral from 0 to 4 of x with respect to x. What this is saying geometrically is that if I have a graph and my function is x, so I'm just going to graph x here. Make a bigger circle. It's supposed to go through 0, 0. What it's telling me is that from 0 to 4, when x goes from 0 to 4, the area under the curve is what this answer would represent. So let's just look at it geometrically. So what if I had this graph? Now I know it's not drawn to scale necessarily, but the base of it is 1, 2, 3, 4, and the height of it should also be 4, since that point is 4, 4. And half of 4 times 4 is 8. Now I'm not going to ask you to just graph all of these and find the area, because frankly a line is easy, but try to do it with a parabola or a cubic or an exponential function or a natural log. It's not easy. In fact, it's downright difficult. We can only estimate it. However, this procedure that I'm going to show you allows us a different way of evaluating it. And here we go. All right, my function is x. What I want to do is take the antiderivative. So remember, that's x to the power of 1. So I raise it by 1, and then I divide it by that power. So 1 raised by 1 becomes 2. We divide by 2. That's the antiderivative. Now, last week we put a plus c on it, and we called it a day. Not today. Since we have these values, we're going to evaluate it from 0 to 4, which means I'm going to plug in the number 4 into this equation. So it's going to be 4 squared over 2. Then I'm going to subtract the bottom one. So I'm going to plug in 0. 0 squared over 2. That's kind of, redundant, but 4 squared is 16. Half of 16 is 8. And 0 squared is 0. 0 divided by 2 is 0. Minus 0. Okay, the answer is 8. So today, we're going to look at using this method to solve these integrals, and to solve these definite integrals. I've also included in this email, along with the link to this video, but I've also included a worksheet with 16 problems. We're going to do 8 of them on this video. I want you to do the other 8 and have that ready to go by Thursday. Here we go. Here's the procedure every time. We take our function, 1 over x, take the antiderivative. And remember, the antiderivative of 1 over x is natural log of x. You cannot use power rule on it. It wouldn't work. So the antiderivative of 1 over x is natural log of x. That's it. All done. From 1 to 2. That's how we say it. Now you notice I didn't put brackets on this one. And you don't have to put brackets. I tend to do that when there are more than one term. If there's one term, you don't necessarily need it. But what I say now is I plug in 2, natural log of 2, minus, plug in the 1, natural log of 1. I don't know if you remember or not, but the natural log of 1 equals 0. So a non-calculator answer would just be natural log of 2. But if you wanted a decimal approximation, you could just plug that in here, and we would get the answer of about 0.693. That's how we do them. We'll just do a couple more examples. What's the antiderivative of e to the x? E to the x. Evaluate it from 1 to 4. Plug in the 4, subtract, plug in the 1. Pretty simple. That's all we can do. If we don't have a calculator, that may be the best way we can write it is right there. That's it. if you had a calculator, suppose we give it a numerical answer, but, and I guess we might as well for here, e to the fourth, let's see, minus, I don't know why I typed this in, I could have just hit e. Either way, the answer is 51.879880. Okay. All right. This one might be a little trickier to take the antiderivative of, because the only thing you know, unless it's an e or natural log or a trig function, you only know power rule. So this is going to take just a little bit more work, so I'm going to have to break this up. We're going to divide both terms by x squared. And the better you get at math, the quicker I hope you recognize these things. 1 over x squared. That's really x to the negative 2, and we can use power rule on that, because you can raise that power by 1 and divide by it. Now, x over x squared becomes 1 over x. Not 4. That was weird. It becomes 1 over x. Now, I did not write it as x to the negative 1, because I know what the antiderivative of 1 over x equals. It equals natural log of x. So let's do those antiderivatives. The antiderivative of x to the negative 2, so you lower it by 1. I'm sorry, you raise it by 1. X to the negative 2 raised by 1 becomes negative 1, and divide by that. These two should always be the same when you use power rule. The natural log of x is the antiderivative of 1 over x. Now I got to plug in numbers. So I got to plug in two different numbers. Be careful. So I'm plugging in 2. Before I plug this in, I'm going to rewrite this just a little bit, just to make this nicer. X to the negative 1 is really 1 over x. That might be a little bit nicer. All right, I'm going to plug in 2. So I get negative 1/2 minus natural log of 2 minus, now I'm going to plug in 1. So negative 1 over 1 minus natural log of 1. All right, so again, negative 1/2 minus natural log of 2 minus negative 1 becomes a plus 1. Natural log of 1 is 0. So our answer would be, so negative 1 plus 1 is 1/2 minus the natural log of 2. You can throw it to your calculator if you want. Negative 0.193. Okay. A couple more examples. We're going to use power rule, because that's all that we know. So we have to rewrite it as a power. So remember, if you're raising it by 2x squared, so it's 2. If it's a cube root, it's 2/3. Now we can use power rule. We're going to raise it by 1. 2/3 plus 1 is 5/3, because we're adding 3/3 to it, divided by 5/3. Just to make it a little bit nicer, dividing by 5/3 is the same as multiplying by 3/5. There you go again. I only have a single term, so I'm just putting the line instead of the bracket. They're pretty much interchangeable. It's really your preference. You'll see it both ways in books. Usually in the books they'll have a straight line. So I'm going to plug in 8. Now don't worry about 8 to the 5/3. You don't even need a calculator for it. Because what's the 1/3 means the cube root of 3. So the cube root, the cube root. So the cube root of 8 is 2. And 2 to the 5th is 32. So if you felt like it, you'd always put in 8 to the 5/3 if you felt so inclined. You would see that 32 is the right answer. Minus, now I'm going to plug in 1. Those 3/5 times 1 to the 5/3 and 1 to any power really is just 1. So this is kind of a little trick here. Think about it as like combining like terms. I have 32 3/5. I'm taking away 1 3/5. So I have 31 3/5. And 31 times 3 is 93/5. Which would be just a fine answer. A fine answer. Okay. All right, one more with an antiderivative. It's a little bit longer, but it's the same thing. The nice part is it's all set up for us. So we don't have to do anything to change it. It's ready to go with power rule. So x3 becomes x to the 4th. So raise it by to the 4th, divide by 4. 3x squared. So the squared raises 1 to a 3, and you divide by 3. And the antiderivative of 1 is x. Remember, because the derivative of x equals 1. Now we're going to plug in these numbers. 3 to the 4th, 3 is 9 and 81. Oh, these cancel, that's nice. So it's just x cubed, which is 27. Or 3 cubed, I should say. And then plus 3 minus, I'm going to plug in negative 1. Negative 1 to the 4th is still positive 1. But it's negative because of that. Negative 1 cubed is negative 1. Put a negative 1 for x. It's actually pretty easy to figure out because there's this nice little thing that happens. Because I get this, plus 30. So negative 1/4 means plus 1/4. And minus 1 is negative 2, but minus means plus 2. And because they're already in fourths, guess what? Negative 81 plus 1 is negative 80. Plus 32. Negative 80 divided by 4. 8 divided by 4 is 2. So that works out to be the very nice answer of 12. Now that's how you do it by hand using an antiderivative. But antiderivatives can get very, very complicated, as you'll find out. So, as many things, we have a numerical calculator way to do this. I want to show you what that is. So if you hit your math button, you're going to notice you got a number 9. Now look what you see. Don't you see pretty much this? All you got to do is fill it in. Negative 1 to 3. Inside the parentheses, put negative x cubed plus 3x squared plus 1. Now you've got to put an x out here, or it's not going to know what variable you're using. So if you put another, if you don't leave it, if you put nothing there, you get an error message. If you put a different letter besides the one you're using, you're going to get a completely wrong answer. It's going to assume everything is a constant, which is not true. If I hit enter, I should get 12. And I do. So let's do the next two problems just using a calculator. Could I use this, do it by hand? Of course I could, but why? Let's just, whoops, I don't want to turn it into a fraction. I want to do math 9. Negative 4 to negative 1. Negative, let's see, alpha y equals, gives us our fraction, 4 over x cubed. There. And I get 1.875. Okay, last one. It's a bit more complicated because it's got an absolute value. And frankly, absolute values make these things a lot trickier to figure out. So let's just, for now, do our math 9 and put it in here. What do we have? Negative x plus. There's probably a alpha function way to get that absolute value sign, but I know it is hitting math and going over 1 to number. That's just the way I know it. E to 3x minus 9. There's a lot of minuses in this problem. Dx. All that for the answer of 9. There you have it. That's how you solve definite integrals. Now, of course, it gets more complicated as our definite integrals get more complicated, but I'll tell you what, the calculator is always this way. Just plug it in. I'm even going to show you another calculator way to do it when I see you again. So, enjoy the rest of your break. I'll see you on the 20th. Until then, take it easy and have a wonderful day. Bye.